All right, so now let's talk about Newton and his three laws of motion. So this GIF right here is gonna it actually illustrates a few of his the concepts that he talks about in his laws of motion, right? And you'll see in a little bit what those are and what this GIF right here has to do with that. Right. One of the things I'll tell you is for every action there's an equal and opposite reaction, and here you're kind of seeing that. But there's a few other things that we can see from this GIF right here. Right, so this is what we're going to be talking about Newton and his three laws of motion. We're going to define and give examples of inertia, know what balanced force and unbalanced force means, know how to define force and give examples, and know how to explain Newton's third law of motion in your own words. Right, so these are going to be pretty important for the final, especially. So just a little bit about Newton himself, right? Sir Isaac Newton, born back in 1643, passed away 1727. So this happened a while back, right? But he was an English scientist and mathematician, and he was famous for his discovery of gravity, also the three laws of motion. Right, and then his book, The Mathematic Principles of Natural Philosophy, is where most of his work is published. Right, but a lot of us know him as this guy, the one who was sitting under an apple tree and just had an apple fall on his head. Right, and this is kind of an urban legend. It's not necessarily that uh, I don't think it's that fell and hit his head, that he just saw apples falling and was wondering, why do apples fall down to the earth, and why don't they just, like when they come off of a tree, float up into the sky, right? Why do they fall down? And so this kind of led to his three laws of motion, which are known as Newton's three laws of motion. And they describe the motion of all objects on the scale we experience in our everyday lives. So that's what's really cool about physics. That it's about things that happen every day that we witness every day, but they actually you quantify everything. So you put math behind every little thing that happens, and you can create sentences and paragraphs just on math, right? Of all these things that happen. And so I really like this quote right here. It's very growth mindset, meaning, it's all about the effort you put in. And he says, if I have ever made any valuable discoveries, it has been owing more to patient attention than to any other talent. Right. So that's what it's all about. I was putting in that effort and just being patient and working on something until you solve it. Right. And so here we're going to learn about F equals ma, force equals mass times acceleration, and one of his more famous formulas. But we'll talk a little bit about this in a second. So, really quick, this question. All right, and so Newton's laws of motion. An object in motion tends to stay in motion. An object at rest tends to stay at rest unless acted upon by an unbalanced force. So this is his first law, and it's known as the law of inertia. His second law right here, and this is something I just read out a second ago, is force equals mass times acceleration. Right, so that F equals or stands for force, the M is for mass, and that A is for acceleration. And for every action, there is an equal and opposite reaction. And this is probably his more well known of the three laws, but we'll talk about them in more detail. Right, so here you see his first law, right? An object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. So here you see the sprinter, and that sprinter is in motion, right? And he tends to stay in motion unless he's acted upon by an unbalanced force. And in this case, that unbalanced force, unfortunately, is that woman who cuts in front of him, right? And he just levels her to the ground, and that's because he can't stop. If he's got that momentum going, and look at his size, right? He's got some pretty big arms. He's got a lot of mass on him. And the female who gets in front of him, she really doesn't, right? And so he just runs her over because he is sprinting, and she just cuts him off and doesn't realize that he's coming with all that mass and all that momentum, and he hits her with all that force and just knocks her on her butt, right? So that is his first law right here in GIF form. And so what does it mean? Right? Basically, it's saying an object will keep doing what it was doing unless acted upon by an unbalanced force. So the guy that was sprinting, he's going to keep sprinting, right? He's going to keep moving unless someone gets in his way, which we just saw someone did. And that ended up stopping him, right? But he put a lot of force behind that hit. And so if the object was sitting still, kind of like the female who was cutting in front of him, right? She was just walking at like a snail's pace. So she was just kind of stationary, and she pretty much just stayed that way until she got leveled to the ground, right? But if it was moving at a constant velocity, it's going to keep moving. And this, you'll notice, doesn't happen so much on Earth, but more in space, right? In outer space is where things will just keep going and going. But it will take force to change the motion of an object.